In this video, we'll take a look at notes at the first part of section 25.2, which is anti-differentiation, or called the indefinite integral. So basically what we're going to do is the derivative backwards. So up to this point, we've been concerned primarily with finding the derivative. So if you have the function f of x is equal to x to the third, the derivative is 3x squared. If g of x is x to the third minus 5, the derivative is still 3x squared. If your function h is x to the third minus pi, which is still a constant, the derivative is 3x squared. So notice, many functions have the same derivative. So many important applications of calculus involve the inverse. If you have 3x squared, how do you find the function that's the derivative of? So given the derivative of a function, find the function. But if told the derivative is 3x squared, we would not know if it came from f of x, g of x, or h of x, or infinitely many other functions differing only by a constant. As it turns out, all antiderivatives of 3x squared are of the form x cubed plus some constant c. So the process of anti-differentiation does not determine a single function, but rather a family of functions differing from the others by a constant. So let's take a look at the symbols, notation, and vocabulary. So the anti-differentiation process is also called integration. So we have a sign, an integral sign, and that indicates the inverse of the derivative is to be found. So the integral of some function f of x, that's called the integrand, dx. dx is the variable of integration. It denotes the independent variable. So this dx tells you what variable with respect that you're going to do the antiderivative of f of x. So f of x dx is equal to capital F of x, which is called the indefinite integral, plus some constant, and we call that the arbitrary constant or the constant of integration. So in that previous problem, if we were to find the integral of 3x squared dx, that would equal the function x to the third plus some constant c. So that's the way that we would write the antiderivative of 3x squared up above is x cubed plus some constant. So how do we find the antiderivative? Well, let's think about an example. Find the antiderivative of the given function. So you know that when you take the derivative, you multiply in the front and drop the power by 1. So if we're taking the antiderivative, we want to go the other direction. We know that it's going to be x to the power of 6, and then a times that, plus some arbitrary constant. So 18x to the fifth, if we take the opposite antiderivative, we know that it's 6 times 6a times x to the fifth. So 18 equals 6a, so a is equal to 3. So that means that the antiderivative is 3x to the 6th plus c. So what did we just do? The antiderivative of the function, basically, remember when you take the derivative. Let me start with my function 3x to the 6th plus c. When you take the derivative of that function, you multiply 6 times 3, you get 18, and reduce the power by 1, and the constant drops off. So if we're going backwards, notice we have to add 1 to the x to the 5th to get 5, and then we want to figure out what we need in the front here, the 3. Notice we took 18 and divided it by 6 to get 3. So to find the antiderivative of a given function, what you basically do, I'm going to go ahead and go down to the next basic rules of integration. So the basic rule, a power rule of integration, the integral of u to the power of n du is equal to u to the power of n plus 1 divided by n plus 1 plus c, where n does not equal negative 1. So up here, what we're doing to each of these terms, when we take the antiderivative, is we're taking 2x squared and we're going to add 1 to the power, so that's 2x to the third, and then we're going to divide by the power, 2 plus 1, which is 3, minus x is to the power of 1. I'm going to add 1 to the power. It's going to make it x squared, and then divide by 2, and then add our arbitrary constant. So the antiderivative is equal to 2/3 x to the third minus, let me write it out, 2/3 x to the third minus 1/2 x squared plus an arbitrary constant. To check and make sure you're right, find the derivative. So the derivative of 2/3 x to the third, multiply the 3 in the front, I get 2x squared, minus 1/2 x squared, multiply 2 in the front, I get x. So, and then the derivative of a constant is 0. So let's try the next one. We have to rewrite so that our function is equal to negative 7 x to the negative 6, so that we can apply the power rule. So when we take the antiderivative, add 1 to the power, I get negative 7x, negative 6 plus 1 is negative 5, and divide by the power, negative 5, plus your arbitrary constant. So the antiderivative would be 7/5 x to the negative 5 plus a constant. So to write it all out, the basic rules of integration, these are the same rules that you had when you were taking a derivative. The integral of a constant du is equal to the constant times the integral of du. So what does that mean? The integral of 3 dx is equal to 3x plus a constant. Think of that 3 as having x to the power of 0. So when you add 0 plus 1, you get 3x. Okay, so what this says is that also means take 3 times dx is 3x plus a constant. So we're applying the power rule to a constant. So the integral of 5 dx, this is why we need to know what the integration variable is. The integral of 5 dx is 5x plus c. So if you have powers greater than 1, that power rule, integral of u to the power of n du equals u to the power n plus 1 divided by n plus 1 plus a constant. So the integral of x to the 7th dx is x to the power of 7 plus 1 divided by 7 plus 1 plus the arbitrary constant. So that becomes 1/8 x to the 8th plus c. So that to check, find the derivative, and you should end up with x to the 7th. So if you have multiple terms or terms with constants multiplied in the front, just like we did with polynomials, if you have a times f of x dx, take your constant a times the integral of f of x. So that means in our example, if we have the integral of 7x squared dx, take your constant 7 times the integral of x squared. So that would be x to the 2 plus 1 over 2 plus 1 plus the arbitrary constant. So that would give me 7/3 x to the third plus the constant. And again, to check, take the derivative and make sure that you're right. The next property says if you have a bunch of terms added in your polynomial, then take the integral of each one individually. All right, so when we find an antiderivative of a given function, we obtain another function, and it's the general form of the antiderivative. And that function is called the indefinite integral because of the arbitrary constant c. So let's practice. So we're finding indefinite integrals. So the integral of 6 dx, that's the integral of a constant, would be 6x plus c. And just a note, if that was the integral of 6 dt, it tells you what the integration constant is. That would be 6t plus c. All right, next example, the integral of 3t squared dt. Take the constant 3 times the integral of t squared, which would be t to the 2 plus 1 over 2 plus 1 plus the arbitrary constant. That would be 3t to the third over 3. The 3's will cancel. We get t to the third plus c. Next example, the integral of 5x to the negative 3 dx. That gives us 5 times the integral of x to the negative 3. So that would be x to the negative 3 plus 1 over negative 3 plus 1 plus the arbitrary constant. Negative 3 plus 1 is negative 2, so that would give us negative 5 halves x to the negative 2 plus the constant. All right, now that you've got the general idea, it's basically the power rule backwards, the power rule from derivatives. So I've got a lot of examples to practice in class. What we'll do is just pick out 2 or 3 of these. So the first group, 4, 5, and 6, notice you have to the power of a fraction. The same rule applies. So if you have u to the negative 2/5 du, then to apply the antiderivative or the integral, take u to the power of negative 2/5 plus 1 over negative 2/5 plus 1 plus your arbitrary constant. Negative 2/5 plus 1 is u to the 3/5 over 2/5 plus 1, which is 3/5. And then we can't leave it u to the 3/5 over 3/5. Dividing by a fraction means multiply by the reciprocal. So that would be 5/3 u to the 3/5 plus the arbitrary constant c. Okay, in the second row, remember to rewrite the function before integrating. So number 7, you would rewrite that as the integral of x to the 1/3 dx. Number 8, you would rewrite that as the integral of x to the negative 2 dx. And number 9, you would multiply that x through to get a polynomial. X times x squared is x to the third plus 3 times x dx. So when you have multiple terms, take the integral of each one separately. So that would be the integral of x to the third, which would be x to the 3 plus 1 over 3 plus 1, plus the integral of 3x, that would be 3 times x to the power of 1 plus 1 over 1 plus 1, plus the arbitrary constant. And then simplify your expression. X to the 3 plus 1 is x to the 4th over 4, or 1/4 x to the 4th, plus 3 halves x squared plus a constant. And again, check by taking the derivative. In the next row, 10, 11, 12, 10 is written correctly. Number 11, rewrite that as the integral of 2t to the negative 1/2 dt before you take the integral. So let's do that one. 2t to the negative 1/2 dt. We take 2 times the integral of t to the negative 1/2 would be t to the negative 1/2 plus 1 over negative 1/2 plus 1 plus the arbitrary constant. That gives us t to the power of negative 1/2 plus 1 is t to the power of positive 1/2 over 1/2. When you're dividing by 1/2, it's the same thing as multiplying by 2 over 1. So we end up with 4t to the 1/2 plus the arbitrary constant. Last example, 13, 14, and 15, you have to rewrite first. So let's see, let's pick number 15 just to rewrite. That's the integral of the square root of t times t squared plus t minus 1. We don't have a product rule yet for evaluating. So simplify the inside of that. That's t to the power of 1/2 times t squared plus t minus 1. Multiply that through. t to the power of a half times t squared. Add the powers when you multiply. So that would be t to the power of 3 halves. Oops, that would be t to the power of 5 halves. Because 2 is the same thing as 4 halves plus 1 half is 5 halves. T to the 1 half times t to the power of 1, add the powers. You get t to the 3 halves. T to the 1 half times negative 1 is minus t to the 1 half. So that's the expression you're taking the integral of dt. Then you would follow the power rule by adding 1 and then divide by the appropriate fraction. All right, same. Number 14, to get that set up, take y to the third and distribute it. Y to the third times 2y would be 2y to the fourth. Y to the third times 1 over y would be y squared dy. So that's what you're finding the integral of. And then rewrite 13 as well. That would be 3y to the 1 half minus 2y to the negative 3 dy. So to follow through, let's follow through on the first one, number 13. Take the integral. We would have 3y to the 1 half plus 1 over 1 half plus 1 minus 2y to the negative 3 plus 1 over negative 3 plus 1 plus the arbitrary constant. So 1 half plus 1, I'll take a couple of steps here with fractions. Y to the 1 half plus 1 is 3 halves, so that's 3y to the 3 halves. Over 3 halves minus 2y to the negative 3 plus 1 is negative 2 over negative 2 plus the arbitrary constant, then simplify. So the last step, dividing by 3 halves, is the same thing as multiplying by 2/3. So I would end up with 2/3 times 3y to the 3 halves. The 3's cancel. I get 2y to the 3 halves minus 2 divided by negative 2. These cancel, and I get plus y to the negative 2 plus the arbitrary constant. So that's antidifferentiation, or integration, is taking the derivative backwards, the inverse process.